In this recording, we're going to learn how to simplify complex fractions. So I'd like you to give yourself the heading on your notebook paper and then write down these 4 fractions that are called complex fractions. And as you're doing so, I want you to think about this question. What do you notice and what do you wonder about these fractions? I'll give you a moment to write it down. So pause the recording and write those down, please. Okay, so hopefully you wrote down each one of those fractions and you noticed something about each one of them. And maybe you wondered, well, what are we going to do with them? Why do they exist? Well, fractions within fractions occur quite frequently in higher level math that we're going to get into. It happens in trig identities, um, happens in expressions that happen to have variables that have values that are fractions. Okay, so it's going to happen, and our task simply is going to be to get rid of the little fractions so that each of these complex fractions has a little fraction within its numerator and or denominator. Let's define formally what it means to be a complex fraction. Okay? I'd like you to write down this definition. So the definition is a fraction whose numerator and or denominator contains one or more fractions. Or possibly a negative exponent, okay? As we had in this last example here. This is a negative exponent. All right, and a negative exponent we're going to learn can be rewritten as a little fraction. Okay, so just as a note, y to the negative second power is equal to 1 over y squared. So if I have a negative exponent, it's going to turn it into a fraction with the exponent becoming positive in the denominator. Okay, so y to the negative second becomes 1 over y squared. The alternative to a complex fraction is just called a simple fraction, the kind that you've gotten used to, like half and 2/3. So our technique when we are encountering a complex fraction is to get rid of it by rewriting the complex fraction as a division problem. So let's write that technique down. Technique. Rewrite complex fraction as division. All right. So 3/4, I guess if I just add a little fraction like 7 over 8, a simple fraction, that's equal to 7 divided by 8, right? That makes sense intuitively. So I can turn this into 3/4 divided by 1/2. Hopefully that makes sense to you. And then we can take it from there. 3/4 times its reciprocal, 2 over 1, which we can simplify from here by, hopefully we recognize there's a common factor here of 2. Let's divide that out. 2, 1. So our final answer is 3/2. Okay, and you can reason about that intuitively. 3/4 divided by 2 would make it smaller, but 3/4 divided by half actually makes it twice as big. All right, so let's get into some algebraic complex fractions. So in this next example, we have a complex fraction with 8 in the numerator and 1 plus the quantity 1 plus x in the denominator. Let's take that same exact approach. We're going to turn it into a division problem, We'll write it as 8 divided by, I have to group the whole denominator. So I write it like this, 1 plus 1 over x. Okay? So it's 8 divided by this quantity. I'm going to put 8 over 1. Now, if you remember from your PEMDAS, your order of operations, we need to do what's in the grouping symbols first. We need to do that operation first. So let's turn this 1 into 1 over 1. So now we've got a fraction, which we now can combine using addition. So I'm going to change this into x over x. All right, multiplying the top and bottom by x. So now I've got 8 over 1 divided by, and now I can add these two fractions into a single denominator. X is the denominator, x plus 1 is up in the numerator. Okay, I think you know what to do from here. It's not bad at all. 8 over 1 times the reciprocal, x, over x plus 1. And now you just need to multiply across. We don't have any simplification we can do, so the final answer would be 8x over x plus 1. Okay, we've done it. We've gotten out of the complex fraction. Okay, this next one, as we said before, if you have a negative exponent, that's going to turn into a miniature fraction. This right here, I'm going to put a line through and say that's basically 1 over y squared. That makes us have a complex fraction. So I'm going to rewrite this 1 over y squared plus 3 over 1. I'm going to turn that into a fraction divided by the quantity y squared plus 1. All right, at this point, you see how here we've got two fractions that need a common denominator. This has a y squared, this has a 1. So I think you're going to find that you're going to multiply by y squared and y squared in order to get that common denominator. All right, so this is looking like a denominator of y squared and a numerator of 1 plus 3y squared times, divided by the quantity y squared plus 1. Let's go ahead and put it over 1, so now it's a fraction. Looking to simplify this division problem? Well, we're going to turn it into a multiplication problem. 1 plus 3y squared all over y squared. And that's multiplied by 1 over y squared plus 1. Now you should try to do some simplification first. Try to factor it out if at all possible. Try to make this work easier. I don't see any way to factor any of those numerators or denominators. So let's just go ahead and multiply across. It's easy to multiply by 1. So 1 plus 3y squared is our numerator. Then I'm distributing the y squared to both of those. I've got y to the 4th. Let me get that right. Y to the 4th power plus y squared. So that's the simplified form that doesn't have any little fractions in it. Okay, why don't you pause the recording and get as far as you can with simplifying this one, then play the recording when you're ready. Okay, so hopefully you worked this one out, give you the explanation of it. We're going to create a little fraction, 2 over x plus 6 over 1. That quantity is being divided by 1 over y. Let's combine these two. We have to do our order of operations. So this needs an x on the bottom, this needs an x up top, multiplying by a form of 1 here. So the new fraction on the left is 2 plus 6x. The denominator is x. We're dividing by 1 over y. That means we're multiplying by the reciprocal of 1 over y, right? So we're multiplying by y over 1. I don't see any way to factor much here. I do see a common factor of 2, but that's not going to be useful. So let's proceed to multiply across. So I see 2y plus 6y all over an x. Sorry, that should be 2y. Let me fix that. 2y plus 6xy. Checking my key there, and I noticed I made a mistake. All right. Hopefully you caught that as well. You're like, Mr. Clinton, the x. You need the x in there. You're yelling at me. All right. This last one is a doozy. We saved this one for last. This is a tough one. It's as tough as they come. But if you can do this, you can do any complex fraction. So let's try it together. Okay? Why don't you, again, write it down. Get as far as you can. Pause the recording. Get as far as you can. And then play when you need a little help or you want to check your answer. Okay, so hopefully you took the time to pause and work this one out. We're going to turn it into a division problem. Okay? 1 over x squared minus 1 over y squared divided by the quantity 1 over y minus 1 over x. Each of these needs to be put into a single fraction. Okay, so common denominator would be x squared y squared. So I'm going to come in here with a y squared top and bottom. Helps to use colors. I'm going to multiply here by an x squared top and bottom. This side I need an x over x. This side I need a y. So if you have any colors at home, that might be helpful. right, so let's rewrite what we've got. We have now a single fraction with a denominator of x squared y squared on the left, and the numerator looks like y squared minus x squared. Now hopefully you're saying to yourself, I think I could factor that. If I end up having to, I could factor that thing. Divided by, same denominator, xy. Remember, the order doesn't matter when I multiply, so whether it's yx or xy, it's the same. The numerator is x minus y. Nice. Rewrite as a multiplication. So if you didn't get as far as this, go ahead and see if you can take it from here. I'm really hoping you could finish this off. So if you haven't finished the problem, pause and finish up. Okay, so we got y squared minus x squared, y squared on the bottom. And over here we have the reciprocal, xy up top, x minus y. Now I see how I could replace this. I'm not going to rewrite everything. I'm just going to put a line through this and replace it with its factored form, y minus x, y plus x. Okay. I'm seeing some simplifying that could be done here. I see a common factor of x, and x is left. Common factor of y. There's just a 1 left over here. So I've got a y left on the bottom. Now I notice these are opposite reciprocals of, opposite binomials. So that's divided out, but they don't make a 1, they leave a negative 1. Right? Hopefully that's not too messy. Let's rewrite what's left. Up top I just have a negative 1 and a y plus x. Downstairs we've got x, y. Okay, so that technique of multiplying, of turning it into a division problem has worked all the way through. Okay, this last one's on you. I want you to pause and work this one out, and then play the recording when you want to see the answer. All right, so hopefully you took time to work this one out. If you have not yet, and you're just looking for me to do it, don't be lazy. Don't shortchange your learning here. Take time to think and work this one out. Play the recording when you've got it as far as you can. Okay, here's the answer. I change it to a division problem. Got my LCD on the left, LCD on the right. Now I can divide by turning it into multiplication by the reciprocal. These are opposite binomials. They leave me a negative 1 quotient. The x's divide out. So all I'm seeing up top is a negative 1. All I'm seeing in the bottom is a 3. Negative 1/3. Thanks for watching.